speaker, uh, Shivalika Sarkar.
Yeah, I'm here.
Hi.
Hi.
So you'll be speaking on STEAM project-based learning approach using robotic telescope data and effective training for future. So the floor is yours, Shivalika.
Yeah, I can share my screen. Sharing is turned off.
Can you share now?
Yeah.
Sorry, you can go ahead now.
Yeah. Yeah, my screen is visible.
Yes. To put it on presentations.
Yeah, it's okay.
Yeah, great. Thank you.
Thank you.
Go ahead.
Yeah. So good morning, everyone. And it's afternoon here in India, but it's morning for everyone there. So the presentation on which I'll be speaking is STEAM project-based learning. And this is being used using robotic telescope data, and it is an effective training for future physics teachers. So this work has been jointly done by me and Amritanshu Vajpayee, and in the guidance of Bonnie Thurber. And this was actually, this project was conducted as part of the 100 Global High School Teams for LCO Processing and Photometry. And under this only, we had trained the future physics teachers on how to use LCO data under a STEAM project, which I will be just discussing in the following slides. And the outline of this project is I'll be just showing everyone an innovative approach to train pre-service teachers in physics, and using the teaching philosophy of STEAM and using the Las Cumbres observatory data. And this STEAM project-based learning methodology actually was developed to train the future physics teachers. And this project was conducted in the session 23-24. And lastly, I will also be discussing how the usefulness and effectiveness of this STEAM project learning was there. And before I begin, I would like to define what we are trying to say about the pre-service teacher. So in India, we have a course of Bachelor's of Sciences, and along with this we have a Bachelor of Education degree also. So we are actually training these students to be future teachers, and after completing the course, they will be actually teaching in schools. Most of them will be taking teaching as a career. So here in our college, in a Regional Institute of Education, Bhopal, which is under National Council of Educational Research and Training, it is an apex body for providing educational training and for also preparing future teachers. So under this project, we will be have the task of preparing the future teachers, and so we had actually planned. These undergraduate students were exposed to the using robotic telescope data, that is we had taken from the Las Cumbres observatory data, and then how they had given training to school students. So this was the project that we had conducted here, and especially the pre-service teachers in physics we had trained. And as you can see that the approach was followed was STEAM, because science, technology, engineering, arts, and mathematics. And you can say arts, A can be for arts also, and A can be for astronomy also. So this approach actually it follows a transversal approach and interdisciplinary connections. And as we have already seen, the keynote speaker has also talked about STEAM and how STEAM promotes 21st century skills. So we had planned a STEAM project using LCO data, that is the Las Cumbres observatory data, and how this project was useful to the pre-service teachers when they got a chance to deal with school students, because that is the ultimate aim of providing this course. That is I already talked about the Bachelor of Education course that the teachers are undergoing through. So this is the approach that we had followed in our project. And as you can see, the steps that we had followed in this project was, first of all, the pre-service teachers were oriented on the LCO activities, how they could collect data from robotic telescopes, because in India, the courses that run, there is no separate paper for astronomy, and astronomy education is actually not very much promoted. So we had to create a non-formal learning environment for the students, and we had to give them orientation on how to use the LCO data, because they had never done that before. And also they had very little exposure to astronomy education. So we were expecting that when they go back to the schools for teaching, so they should be able to actually use the concept that they have learned here for training the school students. So first, we had an extensive orientation session on the LCO activities, which I will be briefing in the following slides. And this was followed by a brainstorming by collective discussion on what the students actually learned from the orientation. And then they were exposed to the selection of the deep sky. The study was actually related to the deep sky objects in the space, and how to identify the deep sky objects and collect the data. And after that, they had to place the request on the LCO website, and then they had to perform the image processing. After this task was completed, the students, the pre-service teachers were actually expected to design some educational activities for students from what they had learned from this LCO image processing and the orientation sessions that we had already given them. And after that, they had actually to realize those activities and those educational activities with students. And then this was followed by taking the feedback from the pre-service teachers. And then we had concluded our project, and the final report was taken from them. So this is a brief synopsis of the activities that we had performed. First was the understanding of the basics of the deep sky objects in particular, and the universe as a whole, because as I already said that these pre-service teachers had very little exposure to astronomy education and astronomy also, because we don't have in our curriculum, there is no separate paper for astronomy. So that was, it was very important for them to understand what are deep sky objects and how they can be actually identified. And the second step was selecting the deep sky objects by the pre-service teachers, which they had to capture and process. So we had actually given them the open question that how actually they will be selecting the deep sky objects. And the third part was data collection using the robotic telescope data on the LCO Global Telescope Network. So these three activities had to be actually performed as by the pre-service teachers who were undertaking this project. And the STEAM challenges which were associated with our project were that because this was the first exposure for the pre-service teachers, so they had to understand that what skills they will be required to learn if they have to use the robotic telescope network data, and if they have to process, so what is the skill that is actually required. And then they had to understand what theoretical knowledge that they will be needing, what the background, how they will be creating that, and then what tools they would require for that processing, and how, what objects, I mean, if they had to identify objects in different seasons, or how they would be able to identify the objects. So that was the challenges in front of the pre-service teachers. And then the observing deep sky objects was the main objective of the pre-service teachers using the LCO Global Telescope data. And since this involved both science, the science of astronomy, of course, and then arts, because they have to really create beautiful images out of what they had seen on the internet, and then it was a challenge for them that how they will be able to create the images of the selected deep sky object. And then technology was obviously involved because they were using many softwares for processing the data. Uh, so the data collection was done using the robotic telescope data, as we have already seen in the conference in this already the Las Cumbres observatory data has already been discussed, and we know that this Las Cumbres observatory is actually a boon for astronomy education, and it is providing a lot of data. Any user can easily access that. And if you have to study different types of celestial objects like stars, galaxies, and exoplanets, so all these can be easily done using, if you are proficient in downloading data from the Las Cumbres Observatory, then yeah, this is actually a very useful tool in our hands. And then we also have a centralized software system which is managing the telescope. So it is, if you, it is very easy, and it is very accessible actually to use the Las Cumbres observatory data. And as I already said, that we were a part of the 100 global high school teams for LCO image processing and photometry. So under this project, we thought that why not? We should train our pre-service teachers in that, because when they will be going back to the schools in future, these concepts will be helping them, and they will be coming out with something useful. And so for image processing, they had used the SAO image DS9 software, and the students were actually oriented on how to use the key features and functionalities of the SAO image DS9, and how they could actually enhance their image, how could they analyze their image, because everything was very new for them, and it was quite challenging for them, because they have never used any astronomy software before, and they were actually quite excited and to use this, and they were actually enjoying the whole process of doing this project. So this is just an example that I have quoted here. This is the Sombrero Galaxy that one of the pre-service teachers and had chosen, and we had asked them that what is the rationale. They had to actually discuss about the rationale for selection of the project, and as one of the pre-service teachers said that considering many factors, I have chosen the Sombrero Galaxy because it is a very large galaxy in the constellation Virgo, and in the month of April, the Sombrero Galaxy is placed in the night sky for observation of most the latitudes, and the galaxy's bright bulge and dark dusty band makes it an interesting object to observe the telescope. So this way, we had actually asked all the pre-service teachers that why you are identifying a given object. I mean, they had to choose the object on their own, and then they had to actually place the request on the kiosk LCO portal. And you can here just I have given an example of the teacher that had placed the request of M104, MSGR 104, which is the Sombrero Galaxy, and then they had to understand the observatory status for the telescope, how which objects will be from which observatory they'll be able to actually collect data, and then they had to download the images. They had to place the request, and then the downloading the images, and which format they have to download. So all these things were actually they could learn when they were actually using the data from the robotic telescope network of LCO. And then the SAO image DS9, they use the SAO image DS9 software to process the images, and you can see this is just an example that I've given for processing. And apart from that,
Malika, 2 minutes, more minutes, please.
Yeah.
You still have two more minutes.
Only 2 minutes left?
Yes,
Oh,
sorry.
I was given 20 minutes. No. Okay.
If we start a little bit late, but well, we'll give you 5 minutes. Don't worry.
Okay, 5 minutes. Okay. So you can see that different exposure time they had used, and they made all the trial and error, and then they tried to see different objects they could identify, like the reflection nebula, the Christmas tree cluster, the Trifid nebula, the Whirlpool Galaxy, then the Cigar Galaxy, Lagoon Galaxy, Black Eye. So these all are the examples, and you can see that using this data, they could acquire actually a lot of skills and knowledge like the magnetic system, the working of telescopes. They could understand the software, then other concepts in physics like right ascension and declination, and various other things, and what best exposure is useful for them, and then what filters actually are used. Now, from LCO GT project, how this was actually helpful in designing the activities for school students. So they had actually planned an activity for the school students, which was related to the electromagnetic spectrum, and then they using the knowledge that they had gained through the LCO GT course, they could actually help the students in designing a simple spectroscope and to observe the electromagnetic spectrum. And the questions actually that they posed were how do astronomers they measure the spectra of objects in space, and what do these objects, and they, initially the discussion was started by showing some images, and the students were asked that how about the reaction on how the images, you can see it's an image of a galaxy and Jupiter, how it is looking different from an optical telescope and from a radio telescope. So students, where you can see students actually made this spectroscope, the school students, and they were all trained by the pre-service teachers, and then they were observing the spectrum on using a mercury lamp or using the sunlight or LED lights, and you can see that students were actually enjoying doing this work and during this project, and they actually measured the spectrum as I've shown on the screen. And finally, we actually took a survey from this pre-service teachers, and we asked them whether they were satisfied with the STEAM LCO activities and whether these activities were actually helpful for them in planning the educational activities for the students. And you can see they were quite satisfied with this. And so in conclusion, this approach is actually very useful. And from training undergraduate students coming down to school students, this the data that is available from the LCOGT network is quite helpful. And following the STEAM approach can really help students in gaining knowledge about astronomy, and it can help in promoting astronomy education. And we would actually like to acknowledge the last Commerce Observatory Project team, Dr. Edward Gomez, Dr. Carton Pennypacker, and the software developers of NASA Micro Observatory GS9 and SAO Image GS9, and Tushar Purohit sir and Shri Mukesh Satankar there with us, and then Team ICE team and participants of the project were also there. And in future, we are planning to go with more school students and with citizen science and with robotic telescopes. And we have already submitted a project, which is the All India Astro Stream project under the aegis of Saptarishi India. And there we are aiming to engage and train students and amateur astronomers globally and especially across India in the study of deep sky objects and opal clusters, variable stars, and exoplanets. And we hope that we will be able to connect many of the students of India, especially where astronomy education is not given that importance. So we will be able to train them with the help of this data, and we will be able to provide them hands-on experience in collecting, analyzing, and interpreting astronomical data scientifically. So I'm very much thankful to the organizers of GSU 2024 to giving me this chance to present my work, and thank you very much.
Well, thank you, Shivalika, for this nice work and impressive, actually, engaging students in what actually astronomers do.
Yeah.
We're running out of time, but we'll give we'll open the floor for some questions, quick questions, please, or comments.
Well, we are waiting for Facebook, but no questions yet. But I'd like to congratulate Shivalika for the amazing work and use of the telescopes and images. That's really nice.
Yeah, excellent. I think you are working closely with Edward. No?
Yeah.
Yeah, Amritanshu is actually working close with Edward Gomez, and I'm a part of that project also.
Oh, excellent.
Yeah, well done, Edward.
Do you have like some statistics on how many students you are impacting each year?
We had initially started with 250 students, yeah. Every day we would call 50 students and we would try to train them. And now we are trying to increase this number from 250. We are planning to go to 500 and 1000. Gradually, we might pick up, because here in India, you know, astronomy education is quite it is not like, it is lagging actually, because we don't have it as a part of the curriculum. So that is why we are trying to impose it through non-formal learning methods.
Are these students are in the same location, or they are spread out all over India?
Right now, we had started with Bhopal, and some students are under Amritanshu, and I think throughout India we had around 1000 students. But we are trying to increase that number, because if we reach to more students, then I think that will be more beneficial.
Excellent. So wish you the best, and hopefully next year you show us actually more impact on this.
Yeah,
Okay,
yeah.
so I'll give the floor to Gustavo if you have any comments. And
No, we need to call for the break because
okay,
it's back in 5
thank all
minutes.
the speakers for this morning. It was wonderful. Thank you very much. So we'll have a break for how long?
5 minutes.
Short break. Okay.